Welcome back. I have Selena here with me, and we are going to be talking about something new and fun. At least it's new and fun for some of you. For some of you, this is review. And we are going to be talking about another way to measure. We've been doing a lot of area work, and now we're going to try something new. So I have a solid figure here. What solid figure do I have? A cube. This is a cube. A cube is a solid that all of its faces are squares. So it's a square on the base, and all of the sides are squares, and the top is a square. So a cube is pretty cool. A cube is one of my favorites. I say that about all of them. Okay, so we are going to be talking about this. We're not going to find the area of this because area is a way of measuring a flat surface, like the surface it's sitting on. We could find the area of this. But what we're going to talk about is how much space is inside of this solid figure. This solid figure, this cube, takes up space, and the amount of space it takes up is called the volume. So we're going to find the volume of this cube. Okay, the way we're going to do that is we're going to use our 2 centimeter volume material. I'm using the box as my workspace. So these are the cubes that I'm going to be using, but I wanted you to be able to see my work surface. And so that's what the cube is sitting on. So to measure the space that this takes up, we can't just guess. We can't draw on it to find it. But what we can do is use these 2 centimeter cubes to build the shape. So I can put one there, and one there, and one there, and look at that. I went across. So we're going to keep building. Selena, you want to help me build this right here? Okay, look at that, we did it. We built our cube. Not really. Oh, we built our cube on that side. Look, when we look at it from the side, it's the same size, right? But it's not the same size in this direction. Okay, so what you're telling me is we need to build it like that to make it the same. Okay. Okay, there's our cube. Look at that. We've got our cube that's the same right there. And we've got our cube that's the same right there. What do you think? Did we do it? No. Selena's unhappy with the fact that I left it empty on the inside there. She says it's not quite the same yet. Okay, let's fill it up. Everyone short? No, it just was hidden from us. Okay, now you can see that we have made our cube in every direction. It's the same size here, and in the front, and on top, and on the back. And we have built our cube. Now we truly have built our cube. Okay, I'm going to switch our view and we're going to decompose or take our cube apart so we can look at it, because how many cubes make up this, how many of the small cubes make up this cube is the volume, or how much space it takes up inside. So when we look at this, you can see that they're right here. We can take these apart and count each individual one. Like we can say this is 1 unit squared and 2 unit squared. So we could do that. Or we can look and see how many are on the top here. How many do we see there? 3 and 3. There's 9. 9. So if I take this layer off and set it over here out of the way, there are 9 cubic units down here. Okay. What about this layer? There's also 9. Oh, I can pull those down. Ah! I thought I could get it in one hand. Okay, and then what do we still have up here? 9. So when we built this cube, we ended up making 3 layers of 9 cubic units. I bet you guys can multiply by 9. What is 3 groups of 9, or 3 times 9? 20. So we had 9 plus 9 plus 9, and all those together equal 27. And the way we label cubic units, because these aren't flat like square units, these are cubes. It's a cube, it's 3 dimensions. So the way we write this is we write units and a 3. We've talked about what cubing means and what squaring means. A 3 up there means in 3 directions. We have 1, 2, 3 directions, or 3 dimensions, and so it's 3 units cubed, units to a 3, 27 cubic units. So that is how we find the volume of a figure. We find out how many of a measure fit in there. These were, I was calling this a unit. They're also, we know they're 2 centimeter cubes, so we could find the actual volume of this by knowing that each of these is 2 centimeters by 2 centimeters. So we could figure that out. But that is work in our next lesson. And so we're going to tidy up this space, and we'll be right back to talk more about area or volume and how we find the volume of a figure. Okay, we got our workspace tidied up and some new material out in front of us. We were just working with this cube, and maybe you've noticed on the shelf that we have a large rectangular prism. It's on the shelf at school, so Selena and I made ours out of paper. It was so good that we had just had the making solids lesson, so we were ready for that. So here we've made our rectangular prism that we have the real one at school, but we have this paper one here at home to work with. And so if we were talking about trying to find the volume of this square-based prism, or we could call it a rectangular prism, if we were trying to find the volume of this, we'd be talking about, we're trying to find the space that it takes up, how much space is inside this solid figure. And so we need to know a little bit more information. So I'm going to set this out of the way a little bit. I want to show a material. I got to lay it out here on the table, and I want to show a material to you and see if you can make a connection or if it looks familiar to something you've done before. Now look at this material. What does this look like? Well, you know, what kind of material does this remind you of or look like?
The yellow material to find area.
It does. It looks just like the area material. This, though, is the volume material. You can see that it's not flat. It has a depth to it, not like the yellow area material that's flat. These have thickness. And if we want to look at them, I'm going to set these guys back out of the way. If we want to look at it, we can see that the thickness is equal to our unit that we were using in our last part. This is our 2 centimeter cube. The height of this is 2 centimeters, and the grid on there is 2 centimeters. And so what we could do is we could build this up all the way around and make it out of unit cubes. But we don't need to do that, because with the lines drawn on here, and we know how to find area of the flat surface, we can find the volume of this piece. So let's look at what we've got here. What do we have along the base?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
And what along the side or the height?
1, 2, 3, 4, 5.
Oh, this is one we're really familiar with. 10 times 5. What is 10 times 5?
50.
50. We know that these aren't square units, that these are cubic units that made this up. So we could say that this piece here is made of 50 cubic units. Now, then what we can do is we can stack them up. If this is 50 units cubed plus 50 more units cubed,
100
plus 50 more,
150
plus one more,
200
plus one more,
250
250 cubic units. Could you imagine if we had counted out 250 of our little cubes to find the volume of this space? It would have taken us the whole box and all day. So we were able to find the volume of the stack of yellow blocks by finding the area of the bottom one and multiplying it by the height of the finished one. We knew that this was 50 units cubed. 50, 100, 150, 200, 250. It's 50 times 5 cubic units volume. Pretty cool, huh? So I hope that you heard that. That was like the sneak peek. We found the area of one of our pieces, and then we multiplied it by how many units high or tall it was. Okay, we're going to set these off to the side, and I want to show you how we can solve for this using any rectangular based prism that we have. I'm going to tip this down so that you can see it. So here we have our rectangular prism, and when we look at this, we need to determine how many cubic units there are in this prism, but we can't take it apart like we did the layers. But what we can do is we can find out how many unit cubes it is across. 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 cubic units long, but we're not going to build the whole thing. That would take a long time. So what I'm going to do is we built that side. I'm going to slide it around here. And now we're going to build along this side. 1, 2, 3, 4, and 5. Now we have built kind of the framework of the base. We've got 10 along the base and 5 along what we would have called the height on area, but we're going to call it this width, how wide it is. Now we have one more dimension because this is 3 dimensions. We have to do this one right here. Let me turn this around so that it's, there we go. Sorry, it just was bothering me the way it was cut. Okay, so now we're going for the height of our rectangular prism. We've got 1, 2, 3, 4, and 5. When we look at this, we can see that we've got all 3 of the dimensions. These are called the 3 important dimensions of volume, and we can label those parts. When we label these parts, we call this the length. That's a lowercase l. There we go. Let me get cursive. This is called the length. And this is called the width. And this is called the height. The length, the width, and the height. If we were trying to create a formula using this, I'm going to switch our views so that we can see what we're doing here. If we were trying to create a formula using what we have learned, we talked about how we first needed to find the area of the base. Our line got a little crooked there. So when we are looking for area of the base, we don't talk about it in these terms, length and width and height. We talk about it as base, the base times the height. And then when we have this other dimension, because this is the height that comes off of the table, we would call this capital H for the height that comes off. Let's put it right there. Or on top. On top. The height. Like that. And so when we're writing out the formula for this, we could say we could say that it is the volume of our rectangular prism is equal to our first ones we had, which was length times width times height. Length times width times height. We could also say that it's base times h height times the capital H, which is our 3-dimension height. And if we were solving for this one, that would be 10 times 5 times 5, and we already know that was 250 units cubed. You know, those are tiny words. I'll zoom in. So the formula for finding volume of a rectangular prism can be summed up by saying it's the length times the width times the height. Or another way to say it, the second one on the yellow one, it's the area of the base times the height. The area of the base times the height. So you can remember that when you're finding area or volume of rectangular prisms, you can use length times width times height, or you can call this the base times height times capital height, or you can say I'm going to find the area of the base and multiply it times the height. All three mean exactly the same thing. They're just different ways of saying it. Now you can find volume of any rectangular base prism that you would like to, and I can't wait to see how you do this for your follow-up. You're going to be finding rectangular prisms in your environment. So maybe it's a book, maybe it is a rectangular battery, maybe
A cardboard box.
ooh, cardboard. There's lots of cardboard boxes around this time of year. Maybe it's a cardboard box or many cardboard boxes. I want you to find 3 rectangular based prisms in your house or in your wherever you are doing your schoolwork, and find the volume of those. You're going to need to use a ruler, and so you can either use your inch measurements or you can use your centimeter measurements. Just make sure you label which one you use. You're either going to have cubic inches or cubic centimeters, depending on what you measure with. Okay, I can't wait to see what you follow up. Make sure you label it. Maybe it's Christmas present under the tree, #1. Maybe it's baking soda box for baking cookies for #2. And maybe it's battery for the smoke detector is your 3rd one. We have those laying around because we just changed out our batteries. So I can't wait to see your follow-up, and I look forward to seeing you next time. Goodbye.